So you first. You can pick first question first. If we have time, I show you this.
Yeah.
It's be better. Otherwise, it may not relevant to your test. Oh, what I'm doing? I go to the screen. I should sharing the whiteboard. Yes, I'm sharing whiteboard now. Still Victor's. Victor's.
Yeah, this one is about determining the vector equation.
Yes, vector equation of what? Of the straight line?
Yeah.
Yeah, the straight line in 3D space. Yes. Okay. Can you tell me the question? Yeah. What is the condition provided?
It says that this a straight line in a Cartesian plane with the equation 2x minus y equals 8.
Oh, it's a plane or can you write down?
It's in a Cartesian plane.
In a Cartesian plane, that is, can we just draw the graph? So x, y, z. Can you write the equation?
Oh, this is in a 2D one.
2D, right? Okay.
Yeah.
Okay. Just 2D. So it's just what is the equation you have?
Because 8, and we know that the x-intercept equals 4, 0.
Yes, you can. This is a straight line, isn't it? It's just a straight line. So what am I looking for?
And we need to determine the vector equation of this straight line.
So you rewrite this form into the vector form, right? Oh, this is y-intercept is 4, x to 4, but that is equal to 8, negative 8, right? Down where? Can we just give a sketch first? Oh, they are looking for the vector equation for this straight line, right? Okay, I got it. So basically, this you have so many choices. This is negative 4, negative 8. This is 4, right? Can we write it? Can we draw the straight line? Because it's very simple straight line. That's one, right?
Yeah.
Okay, let's see. So according to vector, if you want to write a vector, so we need to find a reference. So any point you can find this. So basically, you need to find a reference. Can we just? This is easy. Can we choose this as reference?
Yeah.
So therefore, can we call this is A? This vector is A. Can we? Now you need to find the position of this point called P at any position x, y, right? And by introducing a position vector. So that is whole idea about this. Can you see?
Yeah.
So all these two vectors are originated from the origin here. So that is R. Okay. So obviously, if you can introduce another vector called B, right? Then we can describe this straight line. Do you want to try? Just use the simple relation, this graphical relation between these two. Basically, we know in this time we know a vector already, right? The R is unknown. R is so basically I give you a chance just to go back some basic idea how to write a vector equation for this straight line based on these three vector.
Oh, for R.
Yes, that's right. R is R is unknown. Yes, so you can see R is you see R equal to x and y, all right? X, y. If it's a matrix form, yes. Yeah, we need to find the two components. So
R is equal to.
Yeah, what is the relation between R and A and B?
R is equal to A plus B.
That's right. Can you write down? So that is actually a vector equation. And in this case, we actually know the A already. Do you agree?
Yeah.
Do we know A? Can you write A in terms of vector? What is yeah, that's right. Now the question is what is B? How to you have to work out how to write the vector B, then that's it. So B must have two components, right? Do you agree? They have two components. One is called X, and that is Y. We don't do I have to draw this, or you understand what I'm talking about?
I get that.
You understand, you get it. Okay. So what is A and Y? So this is X and Y. Do you agree? Be careful. Are these Y? No. Y is different. Can you see? What it's Y? X is not. X is this side. Can you see? How do we denote the A? Sorry, B. How to denote the B?
X over Y.
No, this is general equation for this straight line.
Oh, X is 4 it's 4 minus X, or like X minus 4.
Well, this is 4, right? So this is 4. X minus 4. Yes, right. Yes, X equal to X minus 4. Yes. How about Y?
It's Y minus 0.
Y minus 0.
So it's just Y.
Let me see. Can we write down here? Do you mean this X minus 4? How about Y? Y is determined by this first relation. Do you agree?
Oh, yeah.
That is a straight line for that.
It's 2x minus 8, so it's x minus 4.
Yes.
Oh.
Yeah.
So Y would be the same thing anyway?
That's strange relation, isn't it? Let me double check this. Does that make sense? So we know that they have two interceptions, and alternatively, can we just choose? How can we just find a general equation for the B? X and Y, isn't it? That is how to divide. I think we got it. Do you agree? Is that the same as answer? Oh yes, that is Y. That is Y. Yeah, that's not the same. Oh, that's why I get confused because you give me something identical, right? Yes. So if we solve this Y can be solved. Can you see? That you got that. You got 2x minus 8. Okay, that's better. Does that make sense now? I think that is the question they are looking for, isn't it?
Is that a vector equation? I think it has to.
Do we have to write the I and J?
I think so.
So in that case, this is you can simplify this. Can we say this first vector is 4, 0, right? But the second one contains the two parts, right? So you got a -4 and a -8 plus and x, can you see? Plus x. Oh, that is the gradient. I can see the gradient now. So this is gradient, can you see? Isn't it?
Yeah.
Okay, can you combine these first two vectors? So it's just the sum of two, right? 0 and -8. Yeah, that's it. I think that is a vector. Two vectors. Can you see? Sum of two vectors.
I'll look at the answers.
Yeah. So what is their form? Depending how to represent it as a vector. The gradient here is 1/2. That makes sense, right? Because it should.
It has 4/0 plus.
Can you write it down?
Lambda 1/2.
Yes. Let's see. So the straight line can be written as a k. K is lambda, right? So, or this one we have introduced variable here. Otherwise, we don't know the length, but we're trying to figure out the length, right?
I think we just need the vector equation.
Yeah, this is what we're looking for. This is their lambda, isn't it? Oh, this is x, is variable. This is the result. Do you agree? This is the result.
Yeah.
We got a slightly different 1, 2, and x. So what's wrong with our solution? If we just start from here, this is certainly correct. Do you agree? This formula is correct. And the first one is also identical to the answer, right? The point, the obvious thing, they choose A as well. Do you agree? However, now this one, how did they get this one?
I think it's from this one, because that's equal to 1/2.
Oh, x minus 4. How do you simplify? Can you show me how to solve it? The factor, yeah.
Because this is just 2x minus 4.
You can write it down. Can you write? This is this is a problematic, but how about this one? Did you say you can fix that? Yeah. Oh, you factorize that. Oh, you factorize that.
And then that equals
1, 2. And you multiply, or
I think you just have that as the direction vector.
The direction vector, but from this operation, you always factorize this cofactor x minus 4. Still have x4 here, and they call this lambda, isn't it?
Yeah.
So we don't combine with this vector with the first one. That's weird. Anyway, can we try one more question to get warm up? I was doing something else. Let's go to next page. But this is certainly right. Can you see? This is the equation for straight line. Doesn't matter for 2D or 3D. Let's go to next one. We work out the direction. That is okay. Oh, they are looking for parametric form. So that is why we have introduced the variable. Express this one is a complex number, right? In the polar, okay. Yes, polar form is you have to use this r and theta. You agree?
Yeah.
So you have rewrite this Cartesian form. So basically, you have rewrite this in order to find the two value. Perhaps you can use owner identity, right? So if this is a, can we just write down here? So if you have the complex number, then you should be able to use these two variable. One is theta, another is r. Okay, this is a complex number. Okay, let me see. So this is certainly the complex number, right?
Yeah.
And however, we got it's not clear about their x and y. What can we do? We got this. This is fraction. Can we get rid of? Can we make the numerator real? That could be the one way to go. Found the, the conjugate. Do you know the conjugate?
Yeah.
Yeah, we can get rid of. We can make the denominator real so that we should be able to find the two components easily.
Mhm.
So this is real and this is imaginary. It's 0. How can we do that?
You times both of them by the conjugates.
Yes, conjugate. Yeah, please. Yeah, that's the way to go. Yes. We should be able to get this, we should identify where is the real, where is the imaginary after that.
I think.
Aha, that's good. Oh, that's much simpler. So that in this way, we have successfully rewrite this original form into what we call this called the Cartesian form. So that is equivalent to A plus BI, right?
Yeah.
If you know this AB, how do we work out the theta? How do we work out R?
Inverse tan.
Inverse tan, yes, inverse tan. Yes, right, that's right. Notice this A and B are real number now. Good. I think that just a number you can. Yeah, so finally you should be able to write that is this is I theta form, right?
Yeah. Oh, I don't think we've learned that form yet.
Not yet, not yet.
No.
Oh, because you mentioned the polar form. So that's why I thought, I assume that you know this notation. You are going to learn this actually is very important. That's equal to R multiplied cosine theta plus I sine theta. Have you seen this one? No? Or yes or no? This is very important.
No.
Yeah, you're
I've
going to
seen
learn.
this, yes.
You are going to learn this. This is very important equation by Orner. This is Orner. His owner is, but everything is invented by him. He invented I. he invented I, and also he invented a notation for function.
Oh.
And E, and also E. He invented a lot of things. He published hundreds of papers, several hundred papers.
And I think.
Yes. So R is 2. Yeah. Oh, okay. You can use this notation as well. But this is did your teacher ask you to do this notation?
Yeah, because that's the only one we've learned.
Oh yes, yeah. But better in the future, better use this form. This is a polar form by definition. But it doesn't matter. You know that this point, this complex number can be written as either as Cartesian or polar form. Okay.
Yeah.
Let's go to next. Yep. Go to next one. Oh, you have started complex number.
Yeah.
Complex numbers look similar to the vector, right? They all got the components, x, y components.
This question says to show that these vectors are linearly dependent.
Linear dependent, yes. Two vectors, the relation between the two vectors, right? Whether they are linear dependent or independent. There are three vectors.
Mm-hmm. Yeah.
So there are three vectors. What are asking?
It says to show that these are linearly dependent.
Are independent. So therefore, the linear dependent is that the vector you got what is by definition? What is the condition you learn? What is by definition? What is the linear dependent?
Is that when the cross product equals, like the dot product equals 0?
Cross product equals 0. No. It's well, if you have studied this, let's just recall this is linear dependent. Depending on what you're talking. So if you have the if you can find the coefficient, have you seen this one? So if you have a coefficient alpha plus beta b plus gamma c equal to 0.
No.
Have you seen that?
No.
So that is criterion to make a determine to determine whether these three vectors are linearly independent. Can you draw the graph to perhaps you can see the graph? Can you draw these can you draw these three vectors to see if they have any, if they are parallel or perpendicular? Oh, you have make a scale, correct? Oh, 3. 1, 2, 3, 4, 5, 6, right?
Mm-hmm.
1, 2. First one, that's the first one. Yeah, we just roughly, I just see a sketch to see what is 3, 6, 6, 3. How about third one? 2. So this is ABC, right?
No, wait, I did this wrong.
This is A, this is A, right? B is C. It's looking like they are looking for if this equal to 0. Maybe this is a special case they are looking for, because in this special case, can you see this is general criterion. Now, if you get this the sum of this vector equal to 0, then you can make the same judgment. This is a special case when this 3 coefficient is unit. Can you see? Can we try? Can we try? Can you see the sum of these 3 vector equal to 0?
Sum as in dot product?
No, sum of these 3 vectors. So A plus B plus C. How can we find the sum? Do you remember? So we put the we pick up. This is easy way. That is 5 negative 2, right? If you use some matrix notation, that would be easy. Similarly, there's 6. Can you see 6, 3, right? How about C? You can finish that by yourself. C is how do we write this? The 3 vector in vector form. Then we put the x, y components together. It's 9 is not equal to 0. That's strange. It's not equal to 0. So this has nothing to do with this criterion. Do you have textbook? Have a look. What is the definition they use?
I have the answers to it.
You have answered. So this question is not from your textbook.
No, this is a practice exam.
Practice exam. Okay. So what is answer? What does answer say?
Uh,
6, 3.
The answer says that y and z are both functions of x, and therefore they are linearly dependent.
That makes sense. So x and y are independent of what? What is it? What is?
I can show you the working out that they gave.
Okay. I can stop my side because you see the idea of linearly dependent or independent is idea of the linear algebra. And in that case, that's the definition I use, or the criterion I used is from linear algebra.
Yeah.
I can see what's at this stage. What can you do with this? Okay, so this is a solution, right? So this is 3 vector. Determine the value x, y, z such that equal to 0. X, Y, Z. So they have 3 numbers, right? Or maybe these not independent. Dependent, so they are on the same plane, isn't it?
Yeah.
As long as on the same plane. So basically, you are looking for equation.
Yeah, I think this is the one where you wrote the alpha, beta, gamma thing.
Yes, so you can, that's right. They use ABC, right? They use ABC.
Yeah, they use X, Y, Z for it.
X, Y, Z, okay. Okay, so what they do, they just combine everything and they got the coefficient in front. And net, oh, that's why they net every coefficient equal to 0, isn't it?
Yeah.
That's right. If every coefficient equal to 0, then let's double check. Determine the value x, y, z such that that criteria is satisfied, right? So what they did is just they found the sum. Can you see? They put the sum. And but before that, oh, that's right. Yes, that's right. This is the same as, so I use the alpha, beta, gamma. They use x, y, z, right? Yeah, they should. Yeah, that to solve this, to answer this question, you should know the definition. Okay, so if this is definition, then we eventually they work out these 2 equations, right? 1 and 2, and from 2 we solve that. Substitute 3 into 1.
There's more. I'll show you the rest of the working.
Yeah. Yeah, do substitution. You get y is proportional to x, right? This shows that x and z are both function of x. Hence, the vector are linearly dependent. Linearly dependent. So you have to show that because z is dependent on both. That is the criteria they use. Right. Yes, you certainly have to solve these two plane equation for plane, right?
Yeah.
Graphically, so what does it mean graphically? Does that mean there's no overlap, or they have the cross? Do these two plane cross to each other? I think they are.
I mean they would, right? If
they would,
it's
right?
If it's a function of x.
Yeah, so they will cross each other, right? These two. These two planes should cross each other. That is if you use a vector form, Cartesian form. Yeah, this is tedious, right? You have to go in 2 steps to solve 3 steps to solve this problem.
This is one of the harder questions on the
That is the hardest question, eh? I can tell. So I just referred in this context, when they say the 2 plane of any following 3 arrangement parallel. So in this case, we're dealing with intersection, right?
Yeah.
That's right. Otherwise, that is what they call linearly dependent. Oh, anyway, so that is yeah, it depends on the textbook they use. They have different criterion, the form of different criteria. If, however, if all meet in the common line, what do you call it? If there's all, if the 2 line, oh, that's called a 3. Let's talk about a 3 line. Can we use a vector? Can we use a vector to solve this problem? Because we got the. Can you see that? Can you denote these 2 equations they derived, the 2 plane equation? Can we see if their direction are parallel or perpendicular? Can we have a trial?
Yeah.
What are the 2 equations they derived? X, Y, Z, the sum of X, Y, Z equal to 0. Can you look at your, can you share your screen? Okay, 6, that is, I can copy these 2 numbers here. So we got direction is 5, 6, -2. Another is -2, 3, -5. Okay, do you want to check if these 2 vector, the directional vector, are parallel or not? Can we stop your sign? We use this whiteboard. Now, if you just consider these 2 planes, so we have the directional vector 1 is 5, 6, -2. Another is -2, 3, 5. Can we find the angle between these 2? How can we find the angle between these 2?
The cross product.
Cross product. Yeah. We're interested to know if these are perpendicular or parallel. Oh, these are exactly the coefficient they used, right? These are exactly the coefficient they used here. I think in this case, the angle is not 0, it's no 90 degree.
Yes, probably not.
It's not. Yeah, that is between 0 and 90 degree, right? Now, I just wondering, because this is a slightly different approach compared with in algebra. linear algebra, we just focus on this one. We just try, what we can do is that we can adjust this coefficient as long as we can make everything equal to zero. If we can make the equation equal to 0, then we say that is linearly independent. Sorry, linearly dependent. Can we try to choose different sequences A, B? Oh, this A, B is already used. If we use alpha, beta, gamma, can we just consider this alpha, beta, gamma? Can you work out the set of these 3 numbers so that we can make this sum equal to 0? That's a slightly different approach. You see, 5 plus 6 equal to 11, right? It's very difficult to find that if you multiply 2 if you multiply 2, that would be this just, if you don't have time, we can stop here. Otherwise, you say if you multiply, for example, we just choose 5, can we just use a 2 for alpha? And then that will be this will be the 1. I still use the 1 as the simplest one. In this case, can we focus on the x? Can we cancel that?
And that would be
which number? 8? Yeah, it would be 8. Oh, you're quick. Now, can we share these 3 numbers to cancel y?
-4.
-4.
3.
Yeah. 3 plus
no,
3.
Because we'd have minus 40.
Minus 40. No, not easy. But anyway, that is how this criteria applied. Okay, but doesn't matter. We don't want to spend too much time on this single question. Can we go to next one? Let's go to new page. Yeah, normally they wouldn't ask this question because this is ideas you have to start the linear algebra, not just vector.
It's one. I think it's the complex unfamiliar question.
Yeah, another one.
It says a stone is thrown from a boat towards a cliff at the water's edge. It's thrown up at an angle of 70 degrees to the horizontal.
The velocity, right? Like a velocity. Is it river or not?
Yeah, sort of. It says calculate the height at which the stone reaches the cliff. Given that the
project motion, right?
Yeah.
So what is a project motion or not?
It's projectile motion.
Yeah, project motion. Can you draw that scenario? So if you throw something above the ground or on the ground?
It's a bit above because
above. Yeah, it doesn't matter. It's above the ground. Okay. Okay.
2 meters, and the cliff is here, and that's 28 meters away.
Okay. Well, this is ground, isn't it? So that is the ground. That is high. Yes. It's so the trajectory, the angle is 70, right? Okay. Good.
And it reaches it in 3 seconds.
So the time taken is 3 seconds, right? So the flying time, the whole thing is flying time. Yeah. So what is the height of this mountain?
It doesn't specify.
So what is the question?
It says at what height does it hit the mountain?
Oh, this can we call it a small h, right? Okay. All right. In that case, and it's physics, isn't it? It's a physics problem.
Yeah.
And so, as I suggested, I always choose this the position of the launcher or cannon at the origin. I choose this coordinate. You see?
Yeah.
So in this coordinate, and we got basically with this is our y. This is our x-axis. Do we know the distance from this? Do we know the distance?
Yeah, 28 meters.
20 meters. So this can be
28.
28 is 28 meters, right?
Mm-hmm.
So in other words, this position, can you see this position is 28, or not 28, 28 and 0, right?
Yeah.
However, you have, this is 2 meters, right? This is 2 meters, right? Be have careful. So therefore, the relation between this y, the final, so this position finally arrive at x and y, right? So this y, you have to be careful. The y is equal to h, right? Minus, right? Minus 2, can you see?
Is it -2 or +2?
They are looking for the ground, or +2, yes. Because this h is measured from the ground, right? Measured from ground, or be careful. Does it
Ground, it's like it's measured from when it's thrown.
Oh, the same height, right?
Yeah, because this height is like the person throwing it.
Yes.
And
do we know the initial velocity? Do we know initial velocity?
No, just know that it passes 28 meters in 3 seconds.
Yeah. Okay. We don't know the initial velocity, but we do know the angle, right? It's 70 degrees. In this case, you have to be careful because we choose this as coordinate, which is 2 meters above the ground. Now, if the question, so there we have to be careful. This should be minus, can you see? Because they measure the mountain from the ground. They wouldn't +2 in the first place, right? So this should be take can you -2, all right?
Wait, I don't get why it would be -2.
Yes, this is a bit crowded here. For example, forget about the coordinate. Can you see this is scenario? Can you see this is scenario, and this is a mountain here. So this is a mountain. Do you agree? And this person over here, presumably the height is about 2 meters, right?
Yeah.
You throw something here, it takes 3 seconds. And they are looking for this height. Do you agree? They are looking for the height from the ground, not from his height, not from his top. He threw something here at angle theta. You agree?
Yeah. So wouldn't you add that extra height onto the edge?
Well, we just assume that net is higher. You see, I think we can we just use a different color to draw this coordinate. So these coordinate are going to use. And see, the coordinate is different from the ground. Can you see?
Yeah.
So
but we specifically want this spot. So won't we just add it regardless?
So now this position at this moment is x and y. Do you agree? And x is determined is 28.
Yeah.
28. But what I'm saying is that the y, the relation between y and h is that if you are looking for the height, do we know the height?
No, we have to find the height.
Okay, the height is needed to be found out. Should be y +2.
Yeah.
Make sense? Y +2, not this one.
Yeah, okay.
Okay, this is just a quick question or problem. How do we know the range? So basically we know the range, right? And what is the basic equation can we apply? Do you remember in physics, we have this, is this mathematics or physics exam?
It's a mathematics exam, but we're doing projectile motion in mathematics, so it's a lot of physics as well.
Yeah, that's right. Do you remember what is x? X is equal to u cosine theta, right? Multiply the time taken, right?
Yeah.
And how about the y? Y is u sine theta, yes. A little bit of the mathematics. And the gravitation is downward, okay? So therefore, it is a take half g t squared. That's it. Can you solve this problem by yourself? These are two equations. These are two basic equations.
How do we know what U is?
Beg your pardon?
How do we know what U is?
We just assume we have to include U. Maybe U will disappear, you see. Because this time they give you the T, right? So this is a condition is a little bit weird. So they know the flying time. So therefore, we should be able to work out E, you see.
Yeah, and we can work out U because we know that 28 equals U.
That's good. Yeah, that's right. 83 divided by 3. Oh, you solve this equation first. Okay, you solve this equation. Okay, you solve. Okay, that's fine.
And then if we know U, we can just
write
solve
here. Can you just from equation 1 give some description? All right. So you solve the U, so U can be solved. Yeah. So don't worry. If you know the formula, you should be able to work out the what they are looking for. They are looking for the H, right?
Yeah. So Y.
Not Y.
So then we know that
Y
equals
Y plus 2. Yeah, they're looking for Y plus 2, but we know the formula is for Y. Yeah. That's right. That is Y.
And then all of this
that is
H
Y
equals Y plus 2.
You know the watt. You know the watt is a unit for the power. Watt, right? So what is his name? What is his name? What is the name?
Yeah.
What is the name?
Yeah.
It's a question. It's not a statement. It's not a question.
Yeah.
What is the name? Okay.
But we have H now.
Yes, that's right. That's formula. In terms of formula, that's correct. You don't have to go to numbers. Do you agree?
Yeah. Yeah.
So that care must be taken, all right? And it's convenient. Can you see? It's convenient to write this equation for projected motion, provided you choose the starting point as origin. Okay. I think some students were stuck if they choose this position as origin. Can you see? Let's go to next question. Do you have to go or calculus is in math B, right?
Yeah. But we do some calculus of vectors, but that's easy because it's just math B.
All right. That is a complex number again, right? Solve the equation. The real number 1 to 1, right?
Yeah.
So what's this one?
That's Z. So this is the
Z. Oh, this is Z. Oh, this is Z, right?
Yeah.
Z. Can we copy that? Z plus Z plus 1, right?
Yeah.
Plus 8I equal to, that is a modulus, which is amplitude, right? You need to go to modular. Do you go to module or modular?
Modulus.
Modulus. Okay. All right. How can we solve Z? So Z is unknown, right? Can we rewrite this Z as X plus YI first on the right-hand side? You see, this is a basic idea. This is a basic definition, right? So in other words, you should be able to replace this z by x plus I, yeah, plus 1 plus 8i. Okay, yes. It does modulus. Yes, what can you do? Can you put the real and imaginary part together? Ah, that's good. That's good idea. Yeah, that's good idea. Can you expand? Because this time is you can hardly compare both sides. Can you expand this first? All right. So this is the question. You should be able to work out the two equations. From one equation, you should work out the two equations. In other words, that's right. The real and negative part must be identical. What you doing? The square. Did you square this side? How can you get this term? This double check. How did you get this one? Can you try again?
Because I squared it.
Yes, square that. Can you square that? Do you mean x plus 1 square?
Oh, yeah.
Okay, this is not right.
So I have to factorize it.
Yeah, have to try again. Yeah, try again. That's right. It's 3 term in general. You got a 3 term. Can you cancel any term? Good. Oh, yes. Yeah, we got 1 equations for x and y. Okay. So this is simultaneous equation. This is 1 equation. You only use 1 equation. Okay.
Yeah.
How about another equation? Maybe we can keep this form without the use of square root. What do you think? Can we keep
like y squared?
Yeah, keep this form. You may solve that easily. It's simultaneous equation, right? Yes. Yeah, cancelled, right? So y cancelled. Are they equal? Oh, you solved for, how did you equalize in? Oh, this is the second equation.
Yeah, the second one.
Equation.
Therefore,
so we got, can we write them together, right? We got the first is y squared equal to 2x. Do you agree? This is a nonlinear simultaneous equation. How can we solve that? They have to find x and y, right?
Yeah, so we have to square root it.
Yeah, you got the y's, you got x. Oh, that's right. You have to square root them. Yes, that's right. The square root. But be careful, you got a square root, you should got a 2 possible number, right? If you square root them, you should have 2 possible number, yes.
No.
No? Did you? Oh, you square root the first one, right? Oh, you solved the y.
Yeah, and then we just sub it back into.
Sub to x, right? Okay.
Mhm.
Yeah, that's right. The key is to equalize these two. I just use a coloring. So these two terms must be equal. This term must equal to this term. And this term must equal to this term. Yeah, a little bit algebra too. Did you take into account of two possible value or two pair of solution?
Oh,
when you use a square root, you have to consider both negative and positive. So how did you treat that? Why? Which y did you choose? Which y did you choose? Positive y or positive? So in this case,
positive y.
So you have to. But in the meantime, you have this is y1. Can you see?
Yeah.
Now then you have to choose to have another y. So you got to pay
y2 equals.
Yeah.
Does that mean I have to solve it?
Yeah, you have solved. You have solved x. Yes. I think this question is a bit tedious during the exam, right? You have to spend a lot of time. Even you know the method, you have to spend a lot of time. It's not straightforward. So you got two complex number, which satisfies the same equation. That is the point.
Yeah.
Okay. Any other question?
No.
No, that's all.
Yeah.
Okay. Yes, we have to.
Yeah. So do I just say x equals this and this, and y equals this and this?
Well, finally you will say you will write as z1 equal to x1 plus y1 I, right? And z2 equal to x2 plus y2 I. Depending on what is the number, you just put as a number here, right? So finally, that is the final answer. You got a two complex number. Can you see? And then solve.
Yeah.
Okay. So Monday's test time.
Yeah.
Okay. Good luck.
Thank you.
I think you should be all right. I think except that linear, you have to read back. You return to your teacher's lecture note or textbook, because the definition of linear independent is different, slightly different. Okay.
Yeah.
All right, I will save this. I send it to you.
Yeah.
Goodbye.
All right. Thank you.
You're welcome. Goodbye.